Hey everyone, good morning all. And if you can hear me, please put up a message, okay? Or you can even raise your hand so that I can know that you can hear me very well. And today we are going to start a very important session, right? So you're all preparing for your engineering entrance exams, which is a big deal, okay? And many of you, I think you wouldn't have a proper idea of what to do, how to prepare, and many things, okay? So first, before going to the class, I'm going to address the problems that we are going to face, okay? See, of course, we are going to see kinematics today, okay? We are going to solve lots of problem in it today. Before that, okay, what I'm going to do for you is I'm going to make you understand how you have to prepare for your engineering entrance exams. See, either it be VHEE, SRMJE, or HEE, whatever it is. Okay. One thing we noticed at 100 Learning is the data that is given in most of the websites, it's not exactly right. For example, the syllabus for VIT okay, if you take it, lots of websites actually say that there aren't many questions from kinematics. Okay, they don't even include it in the syllabus. But what we found out is, okay, consistently there are questions asked from kinematics in VIEEE, in SRMJE and AEEE. Okay, so all I want you to do for the next 10 days, starting from today, is follow my instructions carefully. We have done our research, we have planned it accordingly, okay? So the first and the foremost important thing you guys have to do is what? You have to follow my instructions very clearly on what to study, and most importantly what not to study, which is again very important, okay? I'll just make it even more clear for you. Okay, so some of you might have some questions, and one of these questions is, where should I start? Okay, so if I'm going to revise, if I'm going to solve problems in physics, so where should I start? Which chapter is important? And the next question is, should I study every chapter? And if when it comes to every chapter, both in 11th as well as 12th. So should I study all the chapters in 11th, sir? Because I'm very good at 12th because I just completed my board exams. But 11th is kind of, numb for me. I need some help. Like you might feel some things like this. Okay. So you don't need to be afraid. Okay. The 11th part here, is it? It is going to be very simple. I'm going to make it easy for you in this upcoming 10 days. Okay. Not only 11th, as well as 12th, I'm going to make it very simple, very easy, easily digestible for you. Okay, both for your brain as well as for your mind. Okay, so now uh, what we found out, okay, what I wanted to share with you guys very importantly is, okay, from 11th standard you get 30 percentage of questions in these entrance examinations. How many percentage? We get 30 percentage of questions. Whereas in 12th standard, okay, when it comes to 12th standard, here is where the majority of questions come from. You get almost 70 percentage of questions from 12th. Okay, and sir, how many questions do they ask? Well, it changes from each and every entrance. Say when it comes to VHEE, okay, the number of questions is different. Sometimes they ask 30, sometimes they ask 35, sometimes they go before 5 years they asked 40. During the corona, they just asked 10 questions. Okay, so the number of questions is going to vary, but the percentage of questions, right, it doesn't change. Always the percentage of questions, 70% of the questions, it's going to come from where? It's going to come from 12th, and the remaining 30% alone is going to come from 11th. And these 30% of questions, you just need to study specific chapters only, not everything in the 11th, only specific chapters. So what are those chapters, sir? See, you can view them here. Kinematics, laws of motion, work, energy and power, gravitation and properties of matter. So what is properties of matter? Mechanical properties of solids, mechanical properties of fluids, those chapters. Okay, and thermodynamics. And when it comes to thermodynamics, the questions are pretty rare. Okay, so these chapters, these are the ones first we are going to concentrate from today. Okay, from today to the next 4 days, and remaining 6 to 7 days, what we are going to do is we are going to concentrate on 12th. So how we have planned the schedule itself for you is exactly how the weightage distribution is throughout. Just a minute. Okay, sorry. Throughout the course, we are going to spend 30% of the time for 11th and 70% of the time for 12th. Okay, so is this clear for you? Okay, I just want you to know whether you guys are clear with it. And if you are clear with it, sir, I got it, sir. What we are going to do, I know I'm very clear with it. Okay, if you feel so now, please raise your hands. Okay, if you raise your hands, Abdina, I can understand, so that we can actually go into the chapter. We can actually learn the formulas and solve the problems. Yes, so everyone is fine, right? So good, super good. Now we can start. Okay, and if you have any doubts also, you can ask. I will be completely watching your doubts here, so I will solve every single doubts for you. Okay, you can ask all your doubts, right? Okay, fine. So now, okay, first we are going to start with kinematics, like I said to you. And when it comes to kinematic, there are two simple, easy, basic formulas from which you get a battalion of questions. They keep on asking questions after questions after questions from the simple formulas. Okay, so what are these formulas? One is velocity, the other is acceleration. Okay, one of the formulas is velocity, the other is acceleration. So when it comes to velocity, okay, you can write it as displacement by time taken, change in displacement with respect to time. So how we are going to write the formula for velocity is dx divided by dt. Okay, this is the formula for it. Now, what I'm going to do is I'm going to rearrange the formula a little bit. For example, I'm going to bring dx, okay, the displacement part, to the left hand side, and velocity and distance dt, okay, sorry, time, we are going to move it to the right hand side. So dx is equal to v dot dt. I'm going to write it like this. Okay, once I written it like this, okay, what I'm going to do is, to know the exact distance or displacement, I'm going to write x is equal to integration of v, velocity, dot dt. So what I have done here is I have taught you two formulas. Okay, so one formula is directly for velocity, and what is it? Dx divided by dt, this one. Okay, and if they ask you to find the displacement or distance, okay, you can do it like this. X is equal to integration of velocity into dt. Okay, you just keep it on your mind. I will tell you how to use these formulas in a problem. Okay, when they ask you a problem, when they ask you to solve a sum, how should you do it? That part I will tell you. Now I want you to write down this formula along with me. Okay, so if there are any issues, sir, you're going like very fast, I cannot write it down, sir, you're going like very fast, Abdina, you can just state it. Okay, but you can just state it. I will be watching, I will help you along with the journey. Okay, so next formula, acceleration. Acceleration, you can write it as dv divided by dt. Okay, that is change in velocity with respect to change in time, dv divided by dt, which means then you can write dv, that is we are bringing the change in velocity to the left hand side and other terms to the right, like we did last time. Okay, so a into dt, dv is equal to acceleration dot dt, we can write it like this. So to know the exact to know the exact velocity, we can also write it as what? Integration of a, acceleration dot dt, integration of a dot dt, we can write it like this also. Okay, guys, fine. So now I'll cut, right? So now we know two formulas. Okay, one is for velocity, the other is for acceleration. They are very, very simple formulas, like I stated. How you use it in a problem, how you identify how to use it in a problem, that is the important part, right? And Another thing is a graph. Okay, you also write down this part also. So what is it? See, if you plot a graph between velocity and time, I have to move in the stage. Okay, if we plot a graph between velocity and velocity is in y-axis, whereas time is in x-axis, right? And the graph, okay, the tangent of the graph, the parabola you're drawing, the tangent, okay, it gives the value of acceleration. What it does, it gives the value of acceleration. So dv divided by dt will be equal to what? Slope of tangent A. It will be equal to acceleration in a velocity time graph. Again, I want you to write these things now. Okay, you just write them down clearly. Now, okay, from this formulas, if they ask you a question, how do you solve it? That's the part I'm going to train you now. Okay, so the most important part, okay, begins just now, right? So, for example, here is a question, okay, problem, okay, which they are asking. The velocity varies with time according to the relation v is equal to 3t plus 4. The distance traveled by the body in t is equal to 2 seconds will be. So look at this question. The velocity varies with time according to the relation. They have given a relation. What is it? They have given v is equal to 3t plus 4. That is a relation they have given. Okay. What are the other things they have given? They have given the distance traveled by the body. Okay. In 2 seconds will be. So actually the question is, you have to find the distance. This is what you have to find. And for that, they given the time period, which is 2 seconds. So what can we do here? Okay, what is the formula for velocity that I said to you? You can write velocity as dx divided by dt, right? You can write velocity v is equal to what? Dx divided by dt. So, and this velocity's value is 3t plus 4. That's what they given in the question. Yeah. See, velocity they've given it as 3t plus 4. That's what we are substituting here also. 3t plus 4 in the place of velocity. Okay. Now, what we are going to do is we are going to find the value of x. And to find the value of x, what we did? First, we have to keep dx in the left hand side and then 3t plus 4 into dt. Okay, the dt term here, okay, which is in the denominator, we are bringing it to the right hand side here. Okay, once we have written it like this, okay, now the next step to find the value of x, that is the displacement, what we have to do, we have to integrate, because that's what I said here. Yeah, in velocity's formula, what did I say? V is equal to dx divided by dt. So dx is equal to v dot dt, then x is equal to integration of v dot dt. That's a formula, right? So that's what exactly we are repeating here, but with the values given in the question. That's all. So to find the value of x, we are going to write it like this. Integration of 3t plus 4 into dt. Okay. So next, what we are going to do here is, okay, I'll just go to the next column. So here I will write, okay. So x is equal to, okay, integration of 3t dt plus again, okay, integration of 4 dt. We will write it like this. So now the next step, what we have to do is we have to integrate. So x is equal to, is 3 a constant? Yes. So it is not going to get integrated. So 3 comes out. Okay. Whereas when t gets integrated, it becomes t square by 2. Okay. What it becomes? It becomes t square by 2. Now, one thing, okay, which we should have done earlier. Okay. But anyway, it's not too late, is the time period. See, the time period we are going to substitute as limits here. So what we are going to do is when we started to integrate, okay, we put the integration symbol, right? At the time 0 and 2. These are the limits we have to substitute. So why 0? I can understand that it is given t, okay, time period is given as t, sir. That's why you substituted t in the upper limit. Why lower limit you have substituted 0? Abdina, here, okay, when the body began, initially the time would have been 0, right? Initially what the time would have been 0. So in a question, okay, if you ask, they ask the question like this, okay, find the distance traveled by the body in t is equal to 3 seconds, 4 seconds, 5 seconds, 2 seconds, like this. Then the initial time is what? 0. So we have to put the integration limit 0 to 0 to and again 0 to. Okay, so once we substitute the limits like this, then again see here in this path, again 4 is a constant, which means you can take it out, and if you integrate dt, you will just get t, again 0 to the limits. So you have substituted this, right? Now you have to substitute the limit values 2 and 0. So what happens the next step? 3 into, in place of 2 square you have to substitute t square, you have to substitute 2 square divided by 2 plus 4 into 2. In the place of t, I'm substituting what? 2. Okay, and you don't need to substitute 0 because the whole term is going to become 0, so it doesn't matter. Okay, that's why I'm not doing it. So here 4 divided by 2 is 2, and here 4 into 2 is 8. Okay, so you're going to get something like this, 6 plus 8. So the answer will be x is equal to what? 6 plus 8 is 14. Okay, so that's the answer we get. So we get 14 meters. And okay, so is there an option with 14 meter here? Yes. So here the right answer is C. Okay, so first thing, okay, how do you identify to solve this question? They give velocity in relation with time. Okay, whenever you see an equation where they given the velocity but in relation with time, relation with time means here 3t plus 4, so it is related along with time period. Then to find the distance or displacement, you have to differentiate and solve it like this. Okay, do you get the idea, everyone? Okay, do you know you can solve this? You can understand this? So if you have understood this, Abdina, please raise your hands. Okay, please raise your hands. Yes. So good. Shivaranjani and Mr. Bullet, Sai Geeta. Yes. So if you raise the hands now, I can understand that you have understood. Or if you don't raise a hand now, then I have to think that maybe I have to go and explain again. Okay. So you make sure you raise your doubt. You just raise your hands. Okay. For every question. So now we will go to the next one. Again, see the same model here also. Here, the displacement of a particle is represented by the following equation. S is equal to 3t cube plus 7t square plus 5t plus 8. So they given the what? Displacement, which is S is equal to 3t cube plus 7t square plus 5t plus 8, where S is in meters. They're saying it is in meters and t is in seconds. Okay, they're asking us the acceleration. What are they asking us? They are asking us to find the acceleration. And what is the time period? T is equal to 1. Okay, so we are going to put limits up. The lower limit is going to be 0 and the upper limit is going to be 1. Easier we can identify now, right? So this is the equation, but they are asking acceleration, right? So first what we can do is we can change S into velocity, that is displacement. We are going to convert into velocity. So how do I do it? Velocity is equal to ds divided by dt, right? We have to differentiate it with respect to time. So d divided by dt, 3t cube plus 7t square plus 5t plus 8. We have to differentiate this whole term with respect to what? Dt. Okay, so look at here, it is cube. Okay, so when you minus 1 from it, 3 minus 1, what does it become? 2, and the 3 is multiplied with this 3. Yeah, the 3 here, so 3 into 3 becomes 9. Okay, so 9t square plus, here there is 2, here there is 7. When you multiply both, it becomes what? 14. So 14t. Why t? Because 2 minus 1. You have to minus 1 earlier. So 2 minus 1 becomes 1. So we are just writing it as 14t plus 5. Okay. Now here t to the power, there is 1, right? So 1 and if you minus 1, it becomes 0, and anything to the power 0 becomes 1. So just 5 alone you have to write, plus 8 becomes 0. So from this, what we can find is the equation for velocity is what? 9t square plus 14t plus 5 plus 0. Okay, you don't even need to mention the 0. So now we have found the velocity. Then what we have to do? We have to convert it into acceleration. So if you want to find the acceleration, then it is dv divided by dt. So d divided by dt. See here, the value of velocity, what we have find out, 9t square plus 14t plus 5, right? Again, we have to differentiate it with respect to time for the second time. So when you do it like this, okay, again, look at here 9 and 2. So 9 into 2 is what? 18. So 18t plus 14. Why? Here there is t and it has a power of 1. So 1 minus 1 is 0. So t to the power 0 is just 1. So 18 plus 14 plus 5 becomes 0, right? So 18 plus 14. I have put the plus symbol twice. So I'll just erase it and put it once. So 18 plus 4. Okay, what will it be equal to? It will be equal to 32, right? So the final answer is 32 meter per second square. What is it? 32 meter per second square. Does the option match here? Yes, option C, 32 meter per second square. Okay, so again, a very simple sum from the basics. Okay, a very simple formula and you can easily solve it. So do you guys understand this question also? Okay, if everyone can understand it, yes, very good. So you got it, right? And just a second. Okay, I'll just look for your doubts. If you have put up any doubts, Abdina. It's not loading actually. Just a second, guys. So chemistry. 32 meter per second square. Shivaranjani has answered before. Okay, very good, Shivaranjani. Good. So yes, if you have put up some doubts and if I haven't answered, okay, you just raise your hand so that I can identify. So far so good, right? So now we'll go with the next one, okay? Equations of motion. One of the most important sets of formula, and you're going to get very simple, easily solvable sums from these three formulas, okay? So what are these formulas? The first one is to find the displacement. Okay, it is what? To find the displacement, and sometimes it is going to be height. The question will be like this: a ball is dropped from the top of a tower. It takes 10 seconds to fall to the ground. What is the height of the tower? They might ask a question like this. When they ask a question like this, you have to use this formula. S is equal to ut plus half at square. There are some certain things you have to follow when using this formula. Okay, one is the value of g, acceleration due to gravity. Okay, so when an object falls down, okay, when it falls downward, then acceleration will be equal to acceleration due to gravity g. Either way, when thrown up, you're throwing an object from the bottom to up, okay, கீழ இருந்து மேல, you're throwing it up, then acceleration will be equal to minus g. What will it be? It will be equal to, acceleration is equal to minus g when it goes from down to up. Okay va? So falls down na plus g, whereas it is going up அப்படினா minus g. So remember this clearly. Okay, so this what to find the displacement. The other formula is v is equal to u plus at, the initial velocity, final velocity in relation with acceleration and time, okay, plus at, right? And the third one is v square is equal to u square plus 2as. See, these formulas I think you all remember very well, because when in 11th it's an important derivation. Okay, so you would have derived these things. Okay, so the formula, okay, memorizing the formula is not going to be the hardest part for you. The hardest part is going to be, where should I use this formula? They've given me a problem. How do I identify which formula to use from this? Okay, so that is the most important thing. So first, what I want you to do is, just like before, take notes of this slide. Okay, write it down. take notes of the slide. Okay, once you have wrote it down, I will just come back. Okay, I'll just go to the problems. I will explain exactly how to use, which formula to use, when to use, everything to you, right? So if you are ready for the problem, sir, okay, this formula is fine, but I need to know where to use this, how to use this. That's the important part. So I'm ready for it. You can go for it, Abdina. Again, put up your hands, please. Yes. So super. Shivaranjani has done it. Sai Geeta has done it. Harsha, Mr. Bullet, Sami, uh, Sami Kamitra. I think I don't know how to pronounce it. Sorry. So yes, good. So most of you are alert. Fine, good. So like we'll take a question here. Okay. A stone released with zero velocity from the top of a tower reaches the ground in 4 seconds. The height of the tower is just like the scenario I explained to you. Okay. If they ask you to find the height, generally, then you're going to solve it with S is equal to UT plus half AT square. First, we'll write down what are the values they have given here. Okay. So what are all the values they have given? Abdina reaches the ground in 4 seconds. Okay. So the time period here is 4 seconds. Okay. See, another important data is released with zero velocity. What does it mean? It means that the initial velocity is zero, which is a very, very important factor here. Okay. Initial velocity they've given in the question as zero. And also they've asked us to take the value of G as 10 meter per second square. Generally, we will take it as what? 9.8. But in this question, they've asked us to take it as 10 meter per second square. Okay, ma. So now let us start solving it. Okay. So how do we solve it? See, first we are going to take S is equal to UT plus half AT square. We are going to write the formula down. Okay. So why did you choose S is equal to UT plus half AT square? They asked me to find the height here. Okay. The value of S, which you always call it as displacement. This is the height here. S is the S will be equal to height. Okay. So that's why I choose this formula. Okay. So now what I'm going to do is I'm going to substitute the values here. Whatever the values I know, I'm going to substitute it here. So what are the values I know? S is equal to the initial velocity U is 0. So 0 into what is the time period? 4 plus half, and A is equal to what? G. And what is G is equal to 10 meter. Okay. 10 meter per second square. So I'm just going to substitute it as 10 into, again, see what is the time period? 4. So 4 square. So now we have substituted the values. We have to directly say the answer. That's all. 0 into anything is 0. So 1 by 2 into 10 into 4 square is that, right? So 4 square panna, you're going to get what? 16. So 16 into 5. So yes, will be equal to 80 meter. So that's it. Very, very, very simple. Okay. So if generally they ask you to find the height, okay, a ball is dropped from a building, okay, they've given you the time period, they ask you to find the height, which formula should you use? You should use the first equation of motion, which is S is equal to UT plus half AT square. So have you all got it? Is it easy? Have you all got it? Please share it. Okay, please raise your hands so that I can see you have got it. Sir, I need some more explanation of Dinalum. I'm very much ready for it. Okay. So has any doubts popped up here? Chemistry. Not yet. Okay. So, but you're all staying alert, right? Because I'm not seeing any doubts here. Just for the sake of doubts, you just put yes, sir. I understand by clicking doubt so that I can see that it is properly working. I just don't know whether you're putting up the doubts and it's not popping up here. So just do it for once so that we can all be clear with ourselves. Yes. Sir. Okay. So DNS put up. Very good. Good. Thank you guys. Okay. So now I can understand. Fine. And clear. Okay. Regarding the pace of the classes, okay, for the first day, since this is your first time, and I'm thinking that mostly you are all going to solve problems from today only. You haven't solved that many problems before. Okay. So for the first day, I'm going to maintain a slow pace only. but it doesn't mean we are going to solve less problems. We are actually going to solve lots of problems. Okay. But I'm going to take it one step at a time. From say tomorrow, from day after tomorrow, the pace won't be same. Will start to pick up because you will also be fast. Okay. You will get very fast. So I will also get in the same pace with you. We can move much faster. But for the first 2 days, we are going to move a little, just a little slow so that you could keep up with me. You can actually understand the concepts. Okay. If you understand these concepts of deny, it is going to be very, very, very easy. It is going to make life much, much, much easier for you. Right. Okay. So here is another question which you're going to try with all the energy. Okay. So if a ball is thrown vertically upwards, okay, it is thrown upwards, okay, with a velocity of 40 meter per second, the velocity of the ball after 2 seconds will be, they are asking us to find the velocity of the ball after 2 seconds. Okay. So again, sir, should I use the same formula here? Can I use S is equal to UT plus half AT square here? Now that is a good question. Are they asking you to find the height? You ask yourself, height கண்டுபிடிக்க சொல்றாங்களா? Are they asking me to find the height? No, no, no. Then what are they asking? Then velocity of the ball after 2 seconds. So they are asking us, okay, the question here is final velocity. They're asking us to find what? Final velocity. That's what they are asking us to find. So what are the things they have given in the question? If I look for the values what they have given, okay, they say that it is thrown vertically upwards with initial velocity u, okay, which is 40 meter per second, and g is 10 meter per second square. Here the most important factor is, okay, you have to take g as minus 10 sorry, minus 10 meter per second square. So why is there minus? Because it's thrown vertically upwards. I said it to you right before these two slides. When thrown up, the value of A will be minus G. Okay. So we have to take it as what? Negative. Just remember this. If you forget to put this now, the answer is going to be what? Wrong. Okay, sir. Now what formula should I use, sir? Okay. Now that's the next question, Elia. So you have to look what are the other things they have given. Okay, if a ball is thrown vertically upwards with a velocity of 40 meters, the velocity of the ball after 2 seconds. That is an important one. So t is equal to 2 seconds. So there is final velocity. There is initial velocity. And then the acceleration due to gravity g is given. So I'm going to write it as a, and they given the time period. So we sorry. So all the important values, v is equal to u plus at. This formula is the most apt, most right one. Why? Because we know about the final velocity. It is stated in the question. It is asked in the question. We know the initial velocity, which is 40 meter per second. We know the acceleration, which is minus g or minus 10 meter per second square. And we know the value of time period too. So we can use v is equal to u plus at formula here. We have to just look at the question. What are the data given? And what is the most apt formula out of the three? Okay. So now even you can itself solve it and immediately tell me the answer. I think now you will be super fast, right? So here see, v is equal to u is 40 minus a's value is what? Minus g or minus 10. So minus 10 into the value for time period is what? 2. So 40 minus 20. So the answer is going to be what, Abdina? It is going to be 20. Okay. So is there an option that has 20? Yes. Option B. 20 meter per second, right? Super. So many of you have stated the answer, right? Shivaranjani has already solved the answer and put up the answer also. So which is very good. So that's the pace I'm expecting from you guys. Okay. So if everyone has understood this sum, sir, it is easy for me. I have understood the sum, Avdina. You just put up your hand, okay, so that I can know and we can move on to the next one also, right? So yes, so I'm getting smaller for you so that you can have more area, right? So now we'll move on to the next one. Okay. See, these questions, okay, these are the models from which you're going to get questions for your entrance exams. You don't need to, like go and practice JEE questions or NEET questions. They are a tad bit harder. But when it comes to, say, WITTI, JEE, SRM JEE, or AHEE, the questions will be like this only. It will be very, very simple for you to solve. It will actually be very easy for you to solve. Okay, so you don't need to worry. So this is the toughness level that you're going to actually get in your entrance exams. So, but I have seen questions that are more tougher than this, sir. Yes, definitely. But we'll get at the end of the class, we'll get to those sums also. Okay. So now look at this. Okay. Wow, I'm much smaller now, right? So a car is moving at the speed of 40 kilometers per hour, can be stopped by applying brakes at least after 2 meters. Okay. If the same car is moving at a speed of 80 kilometers per hour, what is the minimum stopping distance? So what they are saying, a car is going at 40 kilometers per hour, they're putting brake, suddenly something comes in between them, so they're putting brake. And if they put the brake up, it stops after 2 meters. It stops after 2 meters. It stops. So what does stops mean? At some point it came to rest. So the first thing I understood from this question is final velocity. Okay, we'll divide the conditions into A and B. So I'm going to take it like this for the initial condition, which I'm going to take it as A. Okay, for A, the final velocity. Okay, the final velocity is what? Abdina, it is 0. So what is the initial velocity of A? Initially, it was moving at 40 kilometer per hour. Okay. Finally, but what happened? It came to rest. Okay. It doesn't look like a U, right? So I will just write it like U. A. Right? Okay. And then what happened? And then the same car is coming at a initial velocity of 80 kilometer per hour. So this condition is going to be B. 80 kilometer per hour for the condition B. Again, they are applying the brakes and again it comes to rest. Okay. So VB again is equal to what? 0. So then what are they asking me to find? They are asking you to find the distance. For the condition A, the displacement S was 2 meter. What will be the displacement for the condition B? This is what they are asking us to find. Okay, so this is the question part. Now what we are going to do is we are going to solve it. Okay, we are going to what? Solve it. So what is the formula we can use here? Okay, they have given the initial velocity, final velocity, and the displacement. So v square is equal to u square plus 2as. Okay, this is a formula we are going to use. Sir, one problem, sir. In the question, they never talked about acceleration itself. If a ball is thrown up, if a ball is thrown from a building downwards, you said that acceleration, I can take it as G10. But this is a car. It is not falling down. It's going on a road. The acceleration is not given. What should I do here? Well, the acceleration here is a constant one. Here the acceleration is constant. So, but how do you say it is constant? They haven't said it as constant in the question. Yeah, I get your point. Okay. So what I'm going to do here is I'm going to make you understand why it is a constant, right? So we'll take this formula. Okay. What are the things they have given in the question? I'm going to substitute. Okay. They have said to me that the final velocity is 0, right? So the final velocity 0 square is equal to u square plus 2as. So what I'm going to do is minus u square is equal to 2as. I'm going to write it like this. So from this, what I understand, okay, is u square is directly proportional to displacement. U square is directly proportional to what? Displacement. Then if I put equal to na, I should have put up a constant, right? That constant here is acceleration. What is it? The constant. Okay, the proportionality constant தான் இங்க what it is acceleration. Just a simple thing. Okay, so the thing you have to note here is this formula. Whenever you see a question like this, an object is traveling initially at some velocity and you're putting a brake or something happens, it stops. Second scenario, it is moving with much greater velocity or much lower velocity. Again, you're stopping it, it comes to rest. Okay, so they will ask you to find the what distance. This time, what will be the distance it covered? See, previous time, what is the distance it will be covered? Whenever they ask you a question in this format, okay, you don't need to, use a whole formula. You can just come to this step. The step u square directly proportional to s. You can just come straight away to here. From this step, you can easily solve it. Okay, so I will just tell you how. Okay, see, I'll just add a page here. Okay, yes. Now what I said, u square, okay, is directly proportional to displacement. Yes, so we can write it like this: u1 divided by u2 illa ua divided by ub is equal to sa divided by sb, and of course I have to put square here. Ua divided by ub whole square is equal to sa divided by sb. That's how we will take it as a ratio. Now what is the value of ua in the question? 40 kilometer per hour. And what is ub? 80 kilometer per hour. So we will substitute it here. Okay, so 40 divided by 80 whole square is equal to, so the displacement for a is what? For a it is 2 meter, and this is for sb we have to find. So now what we'll do here, we'll substitute it as 2 divided by sb. That's it. If you solve this, you will finally get the answer. It will be very simple. So 40, 80. You cancel it, what? You get 1 by 2 whole square equal to 2 divided by SB. And when you square 1 by 2, it becomes 1 by 4 equal to 2 divided by SB. And finally, 2 and 4 gets multiplied, so it is 8. So the final answer will be what? SB is equal to 8. That's it. The sum will be over. With this, it ends. It's very, very easy. So next time they ask you a question like this, from where should you start? You should start from u square is directly proportional to displacement. Yes. So initial velocity of a divided by initial velocity of b whole square is equal to displacement at a divided by displacement b. Okay, that's it. You have to just take a ratio and then finally you get the answer. So does every one of you understand this question also? Can you solve this? Okay, does everyone understand? If you have any doubts, okay, you can ask. And if you have understood now, please put up your hands just like before. I want you to put up your hands. So Shivaranjani does understand, Harshiv does understand, Samika Mitra does understand. Are there any doubts in physics? 4 meter, 8 meter. Yes, 8. 8 is the right one, right? I'll just have some water, right? Okay. Now we'll move on to the next part. Okay, the average velocity part. So the average velocity or average speed, what if they ask you to find these things? Okay, so there are two conditions, two special cases in this, the average velocity and average speed formulas. Okay, the first one is, let a body cover a journey in equal time intervals with different speeds. What does this condition mean? Okay, a body is traveling from one place to another place. Okay, so what it does is, let's just consider it is taking 1 hour to travel. For the first 30 minutes, it's traveling at 50 kilometer per hour, and the next 30 minutes it's traveling at 100 kilometer per hour. So the time intervals are what? Same, 30 minutes, 30 minutes. But for the same time intervals, the speed or velocity is what? Different. Okay, so if they ask you a condition like this, okay, then the formula for it is average velocity is equal to distance 1 plus distance 2 divided by distance 1 divided by velocity 1, okay, or speed of first condition plus d2 divided by v2. So what is this formula? How does this thing come? Abdina, it is very simple. It is actually what it is d1 divided by d2 divided by t1 plus t2. Okay, what you would do normally, velocity, yeah, displacement by time. So d1 plus d2 divided by t1 plus t2. What I have done here is, instead of time, okay, instead of substituting t1 t2, I have substituted it as d1 divided by v1, d2 divided by v2. Sir, but why did you do something like this? Isn't it a little confusing? Doesn't it make the formula harder? Well, technically not. Why? Because the very formula is the clue for you to identify. Okay, when they ask you to find the average speed, average velocity, okay, in the same time you're traveling at two different speeds. So in the type of question, how do I first identify that this is the formula I want to use in the question? Abdina, the first clue is there won't be time period in the question. They will ask you to find the velocity. Please note it down. Okay, what I am saying is very important. Please note it down. They will ask you to find the velocity, average velocity. So what you will think? You will search for distance or displacement under time. You will get the displacement, but there won't be what? There won't be time period. The question made, there won't be time period. Okay, so if there's no time period now, otherwise there will be another value, that is the velocities v1 and v2. So with this, with the help of those values, we can solve it. So that is why for case 1 I given a formula like this. Okay, let's come to case 2 now. Okay, so what is the case 2? Let a body cover two equal distances with different speeds. Okay, now it is again traveling in different speeds, but the distance is also equal. Okay, in this condition, okay, d1 and d2. So d1 and d2 means d1 is a different value, d2 is a different value. But here in case 2, even the distance is same. Okay, d by 2, d by 2, they are equal distances. So we are covering equal distances in different velocities. Okay, first 10 kilometers I am traveling in 50. Next 10 kilometers I am traveling in 100. So distance is same, but the velocity is what? It is different. This is the second case. Again, I want you to write them down. I want you to write these formulas down. And if you have noted them down, okay, if you have noted them now, please put up your hands, because if you have done it up to then we'll go to problems again from this condition also, right? So Sai Geeta and Shivaranjani have noted them down. Whereas DN, what is your name actually? If I could know your actual name now, I could call you, right? And Mr. Bullet is staying silent for a long time. Samika Mitra, yes. So she also has put up her hand. Okay, very good, fine. So see, here is the question. You just look at the question and remember the clues. First thing, a car covers the first half of the distance between two places at 40 km per hour, and the other half 60 km per hour. The average speed of the car is, and they given the options. First clue is what? They actually ask the average speed or average velocity. Okay, whatever it is. But they have not given the time period. So there won't be time period in the question. That's why we wrote the formulas itself like this. Okay, I have to show right here. Really, yeah. So there is no time period. Okay. So, okay, so what are the other values they have given? They given us first half and other half. So distance, they are separating it as half, which means both the distances, are they same or are they different? Abdina, they are equal distances. So equal distances. Now, what is the formula you have to use? This one, case 2 condition. Okay. A body covers equal distances but in different velocities. So V average is equal to, so first half of distance I'm going to write it as d by 2 plus d by 2 divided by d by 2 into, what is the first velocity? It is 40 km per hour. So we will just substitute it as 40 plus again d by 2 into the other velocity is what? The other velocity is 60 km per hour. It is what? 60 km per hour. So I'm going to substitute it as 60. So look at the values here. In the place of velocity v1 and v2, we have substituted 40 and 60. Again, look at this formula. In the place of v1 and v2, that's the part we have to substitute. That's all. Okay, v1 and v2, if you substitute correctly, now you will get the answer. So 40 and 60 we have substituted. Okay, now we can start solving it. D by 2 d by 2 plus d by 2 will be equal to what? D divided by, here I'm going to take d by 2 common. Sir, what do you mean by common? I'll show you. Here is d by 2, here is d by 2. So both the terms I'm going to take them common outside. So then we'll have 1 by 40 plus 1 by 60. Right. Now what we can do is, here is d, here is d. So we can cancel them. dd gets cancelled. Okay. So we'll take 2 to the numerator. D by 2 is there. No, the 2 we are going to take it to the numerator. So if we take it like this, then 2 divided by, okay, now we have to cross multiply. That's it. 60 plus 40 divided by 2400. That's it. Now we have to solve this. Okay. So I think there won't be enough space, right? I'll be writing. If there is no enough space, I'll move on to the next page, right? So here, let me just put a line so that it will be helpful. 2 divided by 100. Okay, 60 plus 40 is 100 divided by 2400. If it goes to the numerator, it is going to be 4800 divided by 100. So 0 gets cancelled. It's 48 kilometer per hour. Okay, it is what? It is 48 kilometer per hour. So which option matches here? The option B is the one that matches. Okay, so everyone has got it. Everyone now you know the right answer, how to solve it, and which formula to identify. So please put up your hands. Okay. DN Hashiv has put up his hand. Good. Okay, fine. Good. And Mike, I think you're new to the class now, right? I haven't seen you before. So Mike, have you understood? Just put up your hand. Okay. And if you guys have asked any doubts, I'll just check your doubts. Okay. If there is any doubts now, I'll just answer you. Good. 48 kilometer per hour. 40 kilometer per hour. Shivaranjani. Okay. Yeah. We have put up the right answer. Sir, I know it's difficult to pronounce my name. You can call me as Mitra, sir. Okay, ma. Okay, I'll just call your last name. Mitra. Fine. Thank you for letting me know. Answer is A. Thank you. Okay. Super. So you're all interactive now. See, that's the thing I want. Okay. I want you guys to be interactive. You have to keep on, talking with me. You have to keep on asking your doubts with me. Not only doubts. If you have understood now, please let me know. Okay. So this interaction, what it does, it makes you more active, more involved in the class. Okay. See, in our schools, I don't know whether you would have been much interactive. Okay. A teacher will be teaching and will be just listening. I don't want that to happen here. I want you guys to be very much interactive with me. Okay. So that you can learn more. Okay. Like this. Graph based questions. Okay. Now I'm going to give you a set of series of graphs. Okay. Displacement time graph, velocity time graph, acceleration time graph. What they will do is they will just give you a question. Okay. They will just give you a graph and they will ask you to identify a graph. Tell me what graph it is, what this graph represents. Okay. So what I want you to do is I want you to follow me strictly and draw the graph along with me. Okay. I want you to draw the graph along with me. Of course, I will share this as PDF also. I will share the notes also. But when you draw it yourself, when you write it down by yourself, it registers even better. Okay. So I want you to follow me correctly. Okay. So here we go. First, we are going to start with displacement time graph. Okay. We are going to start with bar displacement time graph. So the displacement is along y-axis, whereas the time period is along x-axis in this graph. Okay. First thing, if there is a straight line, okay, a straight line like this, Abdina, then what does it mean? It means that the displacement is not changing. The time is continuously changing, right? If you see, Abdina, for different time periods, the time is changing, but all the different time periods, okay, let's just say if it is 10 meter, Abdina, all the time, the displacement is same. It is not changing. It is a straight line. So what does a straight line represent? It represents that in this graph, the displacement S is constant. Okay. If the so you can also write it down. The statement I have put here, you can also write it down. If the graph is a straight line parallel to time axis, how is it? It is parallel. Okay. X-axis or time axis. Time is an x-axis earlier. So they are saying that if there is a straight line which is parallel to time axis shown by the line, it means that the body is at rest. Okay, so this type of graph, what it does say, it says that whatever the object is, whatever the body is, it is actually at rest. It is not moving, which means from this graph, you can say that velocity is equal to 0. Acceleration is equal to 0. Okay, velocity and acceleration are 0. You can just look at the graph and say these details, right? So have you all understood this graph? Have you all, drawn it? Have you all taken notes of it? Okay, if you have done it now, put up your hands. Good. Okay, now we'll move on to the next graph. Okay, we are going to move on to what? The next graph. So make sure everyone you take good notes of it. Okay, again it's going to be a displacement time graph. Okay, but this time again it is a straight line. The only change is the straight line is not parallel to time axis. It is actually inclined. It is inclined at an angle theta. How is it? It is inclined to time axis at some particular angle. So what to do, Illa, what does it mean if it is inclined? If the graph is a straight line inclined to time axis, it shows that the body is moving with a constant velocity. Here the velocity is what? It is constant. Okay. In this graph, okay, the first one here, displacement is constant. The one in the y-axis, it is constant. Whereas in this graph, velocity is what? It is constant. The velocity is not changing. So that is what they are saying in this graph. Okay. So now we will go to another scenario. Again, a displacement time graph. Okay. Oh yeah. Have you all drawn it? Have you all taken note of it? I'm just moving on to the next one. Sorry for not asking. Yes. So Mitra says yes. Shivaranjani, Harshiv, Mike also says yes. So good, beautiful. So now we'll move front. Here see the graph is a curve. Again displacement time graph tha, but here how it is like a curve. Okay. And what happens? This curve which is going upward, upward, upward. At one point you can see that it is starting to drop. Again it looks like it might come down. Okay. It is starting to curve a lot, right? So what does this graph mean? If the graph obtained is a curve, a displacement time graph, okay, here is displacement along y-axis and time along x-axis, okay? And if it is a curve whose slope decreases with time, what happens? The slope is decreasing with time, then the velocity goes on decreasing. In this graph, what does it represent? It represents that the velocity is decreasing. So you can say that here the motion is retarded. Sir, what is retarded? Retarded means that the acceleration is decreasing. Okay. Here retarded means that acceleration is decreasing. That's what it means. Very simple. Okay. So I want you to write this down also. So have you all noted this graph also? Do you have any doubt in this graph? And I'll just have a little peek at the doubts part. Okay. So that I can know whether if you have asked any doubts, which I have not yet identified. So if that now I will answer. Okay. Yes is constant. B. Okay. Okay. Super. Fine. So far there has been no doubts. Fine. So everyone has understood this graph and noted it, right? Okay. Now the last one. Okay. So You said velocity time, acceleration time, but you're saying last one. Yeah, that's the magic here. Okay. See, with this one, with this graph, the types of graph will be ending. I'll just explain it, after we finish this. I'm going to make life much easier for you so that you can easily understand. Okay. So the final graph here for displacement time. Okay. Here you can see whether the graph is increasing or decreasing. Last time what we said is the graph is decreasing. What happens here? Here the curve is increasing. It has an increasing slope. Okay. So if the graph obtained is a curve whose slope increases, which is the polar opposite to the last scenario, the velocity goes on increasing. So this graph states that what the velocity is actually increasing. So here the motion is what? Accelerated. In this graph, okay, here the motion is what? Accelerated. So you have to just draw a graph opposite to the last one, and the whole scenario is also opposite to last one. So what I meant to say before, okay, that it is almost over is there are actually only four type of graphs. Okay, first one is a straight line, which we saw in the first one. The second scenario is a line inclined to the x-axis or time axis. The third scenario is a decreasing, and the fourth one is an increasing. These four types of graph will again come in velocity time graph also. Now we have what we have saw is only displacement time. For velocity time also, again the same four types of graph only be repeating. Okay, so I will just give you a simple clue. Okay, some simple clues on how to remember these things from the beginning. For example, okay, you don't know what graph it is. You don't know, is it a displacement time or velocity time? You just know that there is a straight line. So if there is just a straight line, okay, and if the straight line is parallel to x-axis abdina, then whatever the term that is here, okay, in y-axis, it is constant. Okay, if for example, instead of displacement, there was velocity v here, then this graph represents that the velocity here is what? It is not changing, it is constant. Okay, that's the basic idea. And in this type of graph, if there is an inclined line, okay, then you have to divide these two values. Y-axis divided by x-axis value. Okay, so displacement by time gives what? Velocity. So velocity here is constant, velocity here is decreasing, velocity here is increasing. Okay, now we'll go to velocity time graph. You will see that how easy it is to remember. You can easily remember it. It is very, very easy. So here, see, we will come to velocity time graph. But in this, I will tell you something extra, which is going to help you solve problems even more easier. So what is it, sir? Let's just say there is a car which is moving with a velocity v1. At what time? At a time t1. Okay, a car is there, it is moving at a velocity v1 at a time t1. So what it is going to do is it is going to move, okay, from say velocity v1 to velocity v2. What I have done here is velocity v1 and time t1, I have connected it and put up points a and b like what we normally do in the graph. Okay, but the car, what it has done, it has moved from velocity v1 to v2. And then again what is it going to do is it is going to slow down. Okay, it has now what? It has reached the velocity v2. Okay, well, again it is going to slow down and come back to the velocity v1. So it comes, so what here it happens is we are just connecting these lines like a graph. I'm connecting a and c like a graph. Now, what I want to know, okay, illa what question they will ask you in exam is, okay, it velocity changed, no. Initially it was v1 and then it become v2. So, what is the displacement? A car is initially going at 40 kilometer per hour. Suddenly it goes at 80 kilometer per hour. What will be the displacement covered by the car? That is a question they will ask you. So how can you find out is you just look this area. I'm shading no this part in the graph. You have to look at this part. the area of this shaded region, okay, the area of the shaded region, this will be just the area will be equal to what? It will be equal to the displacement. The area of velocity time graph with time axis represent the displacement of the body. The first thing is I want you to write down this statement. Okay, I'm going off screen sometimes so that you can write it up. Okay, wow. So don't you think sir just disappeared out of nowhere? Okay, so the area of velocity time graph with time axis, okay, it represents what? The displacement of the body. It is representing the displacement of the body. Sir, okay, you're saying all these statements and showing the diagram, but still I don't know what you're exactly saying, sir. A bit it is confusing for me. Okay, so can you help me with this? Yes, I can help you with this. You just come along with me. I will show you how. Okay, see the formula part, the theory part, 100% when you understand aptina, when you solve a problem. Actually, I put up a question before you, and when you solve it now, you'll be like, oh, this is what you're saying, right? That's how you will feel. Okay, so for now, if it is a little confusing in the area part, it is confusing for me, sir. Abdina, just wait along with me. I will explain, but I want you to write it down, note it down. This statement: the area velocity time graph with time axis represent the displacement of the body. Have you all noted down? Have you all drawn this diagram that is on the screen? Yes. If yes, na, yeah, super, very good. All good children, very active. So any doubt? No, so fun. Okay, fine. Now, right, we'll come to the basic thing, the graph that we are looking at. So a velocity time graph. Okay. This time I will ask you some questions, right? In this graph is velocity constant. Okay. So who are all believing here velocity? Okay, sir. In the graph, the velocity is constant. Put up your hands, please. So Mike says yes. DN says yes. Shivaranjani says yes. And Mitra, yes. Harshiv also says yes. Beautiful. That's all I wanted. Okay. See, now from this graph, you know that if there is a straight line which is parallel to x-axis, and here x-axis line there is time, right? You know that the value in y-axis is constant, which means suppose here velocity is constant. Okay. So if the graph is a straight line parallel to time axis, it means that the body is moving with a constant velocity. Here velocity is what? Constant. Then if velocity is constant, acceleration will be what? Zero. So again here acceleration is zero from this graph. Easy, yeah? Super. Hippo. We'll go to next one. Okay. So next one what is going to be is again a straight line, but it is going to be inclined to time axis. Last time there was displacement time, this time it is velocity time. That's all. Okay. So now even if you forgot, okay, I don't know what I should answer now. What you should do, here there is velocity, here there is time. You divide both. Velocity divided by time is what? Acceleration. Then here acceleration is constant. That's it. Easy. So if the graph is a straight line and inclined to the time axis with a positive slope, okay, the slope here is positive, it means that the body is moving with a constant acceleration. Here acceleration is what? Constant. Okay. So it's very simple, right? These graphs are, it's like a magic. Okay. You can understand it very, very, very easily now, right? So now see a decreasing slope. So a decreasing slope should represent what? Here it is acceleration, this curve. So the acceleration is what? It is decreasing. Okay. What if it is an increasing slope? Okay. If the slope is increasing, then the acceleration is increasing. Okay. The acceleration is increasing. So it is very, 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 very easy, right? Now we'll come to acceleration graph, acceleration time. We have completed velocity time in no time, see, because it will take some time for displacement. Basics. But once you got the basic, velocity time will be very easy. And just like that, acceleration time is going to be much easier. Okay. So let us just consider like last time, here is an object which is traveling at an acceleration a1 in time t1. Okay. And after some time, okay, I'm just going to connect it like a graph. So A1, T1, I will connect it and name it A and B points. After some time, what it has done is it has moved to an acceleration A2. So at time T2, it is moving with acceleration A2. And again, I'm going to connect it with the point C and T. Now, what I'm going to do is I'm going to connect A and C like a graph. Okay. AC, I have connected it like a graph. Now, the area here, okay, the area of this region, it will give the velocity. Okay, it will give the what? Velocity, right? So that's what I want you to wrote it down and write it down now. Okay, acceleration time graph. I want you to write it down like this. I'll just add a new page for you. Two key points. Okay, the first one is area of velocity time graph. It will be equal to what? Displacement. Okay, next, area of acceleration time graph. The area will be equal to what? Velocity. I want you to write these 2 points. Okay, I want you to write it. So please write it, right? So area of A, B, C, D, this whole region will be equal to what? V2 minus V1. That is change in velocity, right? Okay. So now we'll come again to acceleration time graph. Again, see the same thing pops up. Okay. Here you can easily say that, of course, here acceleration is constant. What does this graph say? It says that acceleration is constant. When the graph is a straight line and parallel to time axis, then acceleration is constant. Okay. So what if there is an inclined line? Okay. If the graph is oblique straight line having positive slope, increasing slope, then acceleration is uniformly increasing. Here, acceleration is uniformly what? Increasing. That is what this graph represents here. Okay. And if the slope is decreasing, the straight, it is still a straight line, but actually it is what? Decreasing. Initially it is high and slowly it is reducing. The graph is like that. Abdina. Here you can say that it is having a negative slope and the acceleration is uniformly decreasing. So a polar opposite scenario to last time. Okay, an opposite scenario to the last time, right? And okay, with this the graph ends. Okay, the graph part ends. Now what we are going to do is we are going to actually solve questions from the graph. Okay, so that now you will get a very clear idea on what to do if they ask questions from it, right? And for that, I'm going to actually give you a question from VIEEE. Okay, the question next we are going to solve, which I just showed you. It is actually from VIEEE. So now you will understand how easily you can also solve it also. Okay, and like I already stated in the start of the class. Okay, I'll just ask you one question: is everyone okay with the graphs? Okay, have you all understood the graph? Have you all noted the graph? If you have any questions regarding the graph, you can ask me, so that when we solve problems, there won't be any confusions. It will be much helpful for you guys. And have you asked any doubts? Yes, there is doubt from Arshiv. Sir, graph with negative slope keka matangla, sir. So Arshiv, that's what I'm showing here. Okay. If there is a negative slope, abdina, then acceleration is uniformly decreasing. Okay. So I think you would have asked it out before itself. Just now I saw it. So I think now your doubt would have been cleared, right? So okay, super. So now we will come back and continue. Okay, wow. So here is a question from VIEEE. Okay. So yeah, what I came to address is lots and lots of websites are saying actually that there won't be any questions from kinematics. Truth is, every year, okay, or every in between years, they actually ask you questions from kinematics. In fact, now we will go in and solve lots of questions from the VIEEE paper itself. AEEE and SRMJE questions today we are going to solve, right? So for example, the velocity time graph of a body moving in a straight line is shown in the figure. find the displacement and distance traveled by the body in 10 seconds. Okay, in 10 seconds, they are asking us to find first the displacement and then the distance also. So how do you solve it? Okay, how do you solve it from a graph? Remember what I said to you. Okay, area of velocity time gives distance or displacement. The area of a velocity time graph will be equal to either distance or displacement. Actually, you can find both from this graph. Sir, okay, but how do I find this, sir? Okay, so area. See, I'm going to look at this graph and I'm going to see that this part looks like a triangle, right? This part looks like a triangle. And again, here is another triangle. This part also looks like another triangle. And even again, there is another part which is a smaller triangle like this. Okay. What we are going to do is we are going to find the areas for all these triangles. Okay. So let's just say for us to simply identify, I'm going to name it as A, this one as B, and this one as C. These triangles, I'm going to name it as what? A, B, and C. First, I'll find the area of triangle A. So for area of triangle formula is what? 1 by 2 B into H. So 1 by 2 B. Okay. See, the triangle A is 6, right? It is what? Its value is 6. Whereas the height is equal to what for this one? It is straight equal to 20. So what we have to do is 1 by 2 into 6 into 20. We have to substitute it like this, which means here 2, it becomes 10, 60. So area for A is equal to what? 60. This is for first triangle. So likewise, for each triangle, we have to find the values. I will give you a target. You have to find the value for C. I will find for B. Okay, well, that's my part. I want you to find the area for C. Appdiye everyone, okay, after finding it out, please put it in the chat. Okay, so that I will identify, right? So for B, I'm doing my part. I want you to do it for C. Okay, so for B, what I'm here seeing is its breadth is just 2. Here it is 6. Here it is 8. So 8 minus 6 is just 2. Whereas its height, see, what is its height? So here it is C, abdina, it is straight to 20. So it is 20, right? So 1 by 2 into 2 into 20. So it is 10. So here 2 into 20 is 20. So area of B is what here? It is 20. So we have found out 2 areas. The third one, which I asked you to find out, Ilya. So how many of you have found out? How many of you are still solving? C10, C10. For C, it's 10. Super. So Shivaranjani, Mike, Sai Geeta, bravo everyone. Okay. And how can we find that area? So Mike has actually done it. So good. Okay. So everyone has found clear. Super. Okay. So for C also, I'll just solve. Okay. So that you know how to do it. Okay. C for C. Again, it's from 8 and 10. Yeah. So 8 and 10 again 2. Whereas here it is just 10 only. Okay. So I'll just substitute here 1 by 2 into 2 into 10. So 2 cancels, then there will be just 10 only, right? So area for C is what, Abdina? It is 10. Okay, sir. I have found out the area, sir. Now what should I do? That is the next question. Ilya, we have to look at the question. They are asking us displacement. They are asking us distance. Okay. Now, which is a scalar, which is a vector? That is a clue here. Displacement is a vector. It depends upon the direction. Whereas distance It is a scalar. It does not depend upon the direction. What does it mean then? It means that in this graph, okay, you look at B, the triangle B, it is at the negative side. Okay, if it is negative now, while calculating displacement, again I will say B is on the negative, and while calculating displacement, okay, you have to subtract B from A and C. I want you to add what? Add A and add C. Why you are both adding both? Because they both are on the positive side. So 60 plus 10. Okay, it becomes 70. And then you have to subtract 20 from it. Okay, so I'll just solve it here in another page for you. Okay, to find displacement, what we are going to do? Displacement D is equal to 60 minus 20 plus 10. Okay, why? The 60 and 10 are in the positive, whereas this minus 20 was in the negative. So the answer here will be what? It will be 50. Displacement is 50. Okay, now next we'll go with distance. See, distance, it is a scalar. It does not depend upon the direction. What does it mean that it does not depend upon the direction? Abdina, you can just go and add everything. Okay, what you can do, you can just go and add everything. So now distance curve, what we are going to do is 60 plus 20 plus 10. We are going to add everything. So the answer will be what? 90. So we should get two answers. One is 50, the other is 90. Is there an option that matches it? Yes, there is 50 and 90. You have to be careful while picking the options. Okay, here displacement is first, distance is second. So displacement only we got what? 50, and distance we got 90. So the order you should not confuse. For example, some of you might find it correctly, but you will choose D, 90, 50 in some confusion, in some panic. So you have to be calm there. You have to choose it correctly. Okay. So now this sum, okay, how to find using area? Everyone can understand. Option A, Harshiva said yes, correct. Everyone, you all have understood area based questions, how to answer. It is very, very simple. So actually, I'm not. Yeah, super. Very good. So what about Janani, Sai Geeta, Mitra? Have you all understood? Can you put up your hands? Yes. Yeah, come on. You're all hungry, huh? I'm a little hungry, huh? We'll just finish. Okay, we have few more questions, and after that we can finish. So river boat problems here is an important concept. Okay, it is very interesting concept. Okay,